Okay, everyone. So in this video, we will be talking about rate of reaction. And think of rate as the speed of reaction, or how fast or slowly the reaction is happening. So if we were to take an example of a reaction we have seen before, um, and this is a reversible reaction, ammonia breaking down into nitrogen and hydrogen gas. And if you remember, this happened to be an endothermic reaction. We actually saw the reverse of that reaction in our last video. That was exothermic, so this will be endothermic reaction. So, um, what happens uh, when you change the conditions of the reaction is what we're going to be discussing now. So, the factors that will affect the rate of the reaction. The first factor that we are going to discuss is going to be concentration. Now, when you think about concentration, or in general, when you think about the rate of the reaction, what you want to think about is, uh, like we said, it tells you the speed of the reaction. So, think of the collisions that will happen between two molecules for the reaction to take place. So you can see it in both the directions. If I take ammonia, so it needs two ammonia, so one ammonia molecule, another mo ammonia molecule will react and break into nitrogen and hydrogen gas. And in the other direction, nitrogen molecule will react with hydrogen molecule and then make ammonia. So in either of the direction, you can tell that molecules need to collide with each other in order for the reaction to take place. So one molecule A needs to find molecule B in order for a reaction to take place. So if A can find B more easily or B can find A more easily, the rate of the reaction will go up. It'll be a faster reaction. So basically, if you can just increase the concentration, so how many molecules of A we have per unit volume, if you increase that, then the reaction rate is going to go up. So when you increase the concentration, so when the concentration goes up, then the rate of the reaction is also going to go up. Okay, so if you were to add more ammonia, the concentration of ammonia will go up, and that will increase the rate of the reaction because there will be more collisions of one ammonia molecule with another one because now they can find each other more easily. Okay, so again, by rate of reaction, we mean that how fast the reaction is going to go, and that will depend on how easily a molecule can find another molecule. Okay. Now, the second factor is temperature. Now, whether your reaction is endothermic or exothermic, the temperature is always going to increase the rate of the reaction. So the temperature increases the rate in both the forward and the reverse direction. Okay. So again, if you have higher temperature, it can lead to molecules having more collisions because they're moving more faster because they have more kinetic energy in them because that's what temperature actually measures. It's the measure of kinetic energy. So if there are more collisions again because of the higher temperature, then the rate of the reaction does go up. We can actually look at that by looking at the energy graph as well. So you might see this from, might recognize that from previous videos, where if the reaction is happening and we put that on the x-axis and we have the energy scale on the y-axis, and imagine this was the reactant energy and this was the product energy, then, how these reactions take place. So this one looks like an endothermic example because you see how reactants are low energy, product is high energy. Now, earlier, if you remember, we were just showing you that the reactants need to go to the product, so they will just absorb the energy and then become the product. It's not straightforward as that. What actually happens is that when the reactant has to become product, it actually has to cross this peak, this mountain. So um, this is what we actually consider the transition state at the peak, and this is a very unstable state. That's why it's so high energy. I mean, it's high energy. That's why it's so unstable. So a reactant, whether this reaction is exothermic or endothermic, that does not make any difference. Both have to go through this peak, this mountain, to cross this and then they get to the other side. So a reactant has to get to the product, it has to cross this mountain. Okay. Now, if you increase the temperature, then the energy of the reactant is going to go up, right? So if I have reactant in the reaction in the beginning and I increase the temperature, my reactant will now be sitting much higher. So now it has to cross, it becomes easier for a reactant to cross. Imagine now the reactant is sitting up here after you increase the heat, increase the temperature. Now the reactant sitting up here, it has a smaller mountain to cross. And that's what makes the reaction now go faster. Okay. Same thing on the other side. If my reactants were going to the product, then again, if I increase the energy or the temperature, then now the reactant is going to be getting sitting up here. And again, it's getting much easier for it to cross this transition state barrier. Okay. So the temperature basically makes the reaction go faster in both the directions. And whether it's endo or exo, doesn't matter. It increases the rate of the reaction. Okay. So and number three, this is the final one. This is the catalyst that you may add into the reaction. So the catalyst will always make the reaction go faster if it's present, if the reaction if it gets affected by a catalyst. So again, let's try to understand that from what we were drawing earlier as well. So you've got reactants and products. And remember how I mentioned the reactants have to go and cross this big uh, mountain, and we call this the transition state, right? So a reaction again a reactant has to cross this big mountain to get to the product. Now, temperature was one that helps reactant reach that barrier. This is called this energy gap right here. This is called the activation barrier. So you need that for the reaction to even start. Okay. And this can again be in endo or exothermic scenario. So for example, if you have uh, if you have fuel and you have oxygen, both are present in air, imagine, but they are not gonna, the fuel's not gonna ignite on its own. It needs that spark. So imagine of that spark being a catalyst for the reaction to start, because the fuel or the oxygen, they don't have enough energy to cross this transition state. As soon as there's a spark or some heat source, then the reactants now have enough energy to cross the barrier, and that will trigger the reaction, and then a chain reaction can happen in which there will be enough energy coming from the previous reaction to trigger the next reaction, and that reaction will then eventually become spontaneous. Okay, so this is true for both endo-exothermic reactions that they have to cross this barrier. Okay, now what do catalysts do? Catalyst will just lower the activation barrier. Okay, so when the catalyst is present, it can happen by catalyst just having two spots, so two locations on the catalyst molecule where it just acts as, as bringing two molecules together. Okay. So it could be like a charged particle, which brings the active sites of or like the two reactants who want to react with each other, just bring them closer. Okay. So I just used the word active site. So imagine that being used with the term enzymes. You might have heard of enzymes. So enzymes in our body are nothing but actually catalysts that make the reaction go faster. So catalysts will never make the impossible reaction to take place. So a reaction needs to be thermodynamically be possible for the reaction to exist, to take place. The enzymes or catalysts will just make the reaction go faster. So enzymes is an example. Some metals like platinum could be an example of a catalyst, which will again just lower the activation barrier by stabilizing the transition state, and that enables the reaction to go faster because now with that small barrier, the reactants can now more easily cross that barrier it was earlier facing. So that's how catalysts work. So if you add the catalyst, reaction will go faster. If you remove the catalyst, then the reaction will go slower. And with the temperature, just to summarize, the temperature goes up, the rate goes up. The temperature goes down, the rate goes down. You add the catalyst, then the rate of the reaction goes up. You remove the catalyst. So if you remove the catalyst, the rate will go down. Okay, that'll be all for this video.